For this set of notes, we're going to take what we've learned with the last lesson and somewhat set it aside and talk about some of the properties of logarithms. Basically, this is a big lesson on how to simplify logs or expand logs. So you'll see what I mean in a second. So everything you learned here, we're going to hold it, but it's not something that we're necessarily going to use in this lesson. We're going to kind of hold that thought and move on, and then we'll come back to that in another lesson later. So the first three little bullet points that you see basically is a fancy way of me explaining the three big ideas in this lesson. So here goes. We're just going to type it in the calculator. You can just watch. You don't even have to grab a calculator. And notice that there's an understood 10 here and an understood 10 here and an understood 10 here. So I don't have to do the alpha math thing. I'm just going to press log. I just used the log button. So log 10, close parentheses, plus log 6, and I got 1.78, and I'm just going to write that down. So 1.78, and that's equal to, well, let's find out what the log of 60 is. So log of 60, and that's 1.78. Oh my goodness, they're the same. The point of that is this. This is equal to that. So now let's look and see what happened here. Log of 10 plus log of 6 is log of 60. How do I take a 10 and a 6 and turn it into a 60? I could multiply them, right? Okay, so here's the idea. When I'm adding logs, I multiply. I'm going to slide the paper up, and I'm going to write that down. When adding logs, multiply. Now, I have oversimplified that explanation. There's a couple things I left out. When you're adding logs that have the same base, these both have a base of understood 10, you multiply to create one log. So I will write that, to create one log instead of having 2 or 3 or ever how many. So log of m plus log of n. M and n are just regular numbers. I said regular numbers. Let's call them real numbers. Non-zero, non-negative numbers. This would really be log of, well, m times n. So if you're looking ahead, you're seeing this and you're realizing what's about to happen. We're going to multiply 5 times x. We'll get to that though. So here's big idea number 1. When you're adding logs, you multiply to create one log. Let's slide up. You know what's about to happen probably. We're going to type this in. We're going to be like, oh, wow, they're the same. This is amazing. And you'll realize that they're the same, and it is truly amazing. So log of 100, which by the way is 2. I just want to point that out because like 10 to the second would give you that. Anyway, minus log of 50 is going to give me 0.30. So I like to put unnecessary zeros. And then log of 2 is 0.30. Oh, surprise. Ah, this is amazing. Yay. So what am I doing? What's the big idea I'm going to carry away from this one? And it's this. So how do I turn a 100 and a 50 into a 2? I could divide. So when I'm subtracting logs, I can divide to create one log. So I'll write that down. So when subtracting logs, and the thing I'm leaving out is the logs have to have the same base, and we'll deal with that possibly. Maybe not in this lesson. But, don't subtract, you divide. You divide to create one log. And so if I had log of m minus log of n, where m and n are positive numbers, then I could just divide them and be like, well, m divided by n. So m over n. Don't make it harder than it is, right? Okay. So you know where this is going. When I do the next one, you're going to say, oh, wow, they're the same. Please make the torture stop. I hear you. So 2 log 5 and then log of 25 are the same. If you want to waste your time saying that 1.4 equals 1.4, you could. But now this one's a little more obscure. I'm going to put a 0. Good habit. This one's a little more obscure. You're probably like, how do I turn a 2 and a 5 into a 25? I'll go ahead and tell you. What I'm going to do is let this 2 come up, and it's going to become an exponent. So this is really going to be log of 5 squared. So big idea number 3 is coefficients of logs, I'm running out of space to write things, become exponents. And so I'm going to take this k, and it's going to come up, and it's going to be my exponent. And so my answer down here is going to say log of m to the k. And don't be mad because all the numbers went away. We're doing this to represent numbers. Maybe that's a 2, maybe that's a 3. Who knows what they are? But we needed this to kind of realize what's going on. Okay, so down here I've had to make a few corrections. Yours will be correct. But here goes. Let's start with the first one. I'm adding logs. When I add logs, then I will create one log by multiplying. So, one log, one logarithm, and 5 and x makes 5x. Some people put parentheses, some people don't. It's implied either way. I'm going to leave it. We're done. That's it. It's that easy, I promise. We're subtracting. When subtracting logs, divide to create one log. So, and we go from left to right. Don't be like, oh, it's x divided by 5. Don't go backwards. No. 5 divided by x. And write it like a fraction. 5 over x. Now, that's wrong because we left off our log. There we go. And you're probably like, man, this is ridiculous and very impractical. It's going to become very practical when we're solving these. And you'll see the practical application of logarithms. Go ahead and tell you right now, though. Decibels, the measure of the volume of intensity of sound, is measured on a logarithmic scale. So is the Richter scale, earthquake. So logarithms have a wide range of applications. Okay, well, let's talk about what wasn't said in number 1 and number 2. And then we'll deal with number 3. I'm going to point to a number, and you tell me what I'm pointing at. Well, it's a video. You can't really talk back to it. So that number right there, not the 5, is a 10. And that's a 10, so that's a 10. Okay, so let me state the obvious. 10 and 10 makes, well, 10. It didn't change. I'm creating one log, and that log has the same base. So when I do this, don't be like, well, 2 and 2 makes... It's 2, okay? I'm not adding the 2's. I'm not multiplying the 2's. The base is 2. It's the 5 and the x that I'm dealing with. So the final answer on this one is creating one log with the same base of 5 over x, in parentheses or not, okay? The next problem looks the same, but it's not, and this is where things get a little bit different. I'm going to start every problem now by looking for coefficients and saying, you coefficient, you move up. So I have log base 4 of 5 minus log base 4 of x to the second power. Okay, we've gotten that out of the way, and now we say, oh, well, I'm subtracting logs, and my logs have the same base. So when I'm subtracting logs and they have the same base, I'm going to divide to create one log. So, final answer, I'll write it in blue, I don't know why, is log base 4 of 5 over x squared. And that's it. Let's keep moving. We have 4 more in this section. When we do this, and this, and this, and this, we're going to start by looking for coefficients. And those coefficients will move up and become exponents. So I'm going to take my green pen and look for coefficients. I don't see one here. Understood one. Nothing here, nothing here. Okay, we're good. Now here we'll move that up in a minute, and here we'll move that up in a minute, and that one, and that one, and that one, and yeah, but not yet. So don't make it harder than it is. Go from left to right and just do 2 terms at a time. Don't be like, oh, I have 3 things, I'm going to divide and then multiply. Yeah, but hold that thought. Hold your horses if you possess horses. Log base 2 of, make that third one wait his turn, 30 divided by 6. 30 divided by 6. It's 5. I should have put 5 and not wasted your time, but I didn't. I'm sorry. So, one extra step. Log base 2 of 5. 30 divided by 6 is 5. There we go. Now I'm adding logarithms, so I will multiply. So I really have, final answer, log base 2 of 5 times y. This is acceptable. Some people put it in parentheses. Either way is good with me. The next one has a coefficient that needs to become an exponent. The 1/2 is going to move up. So the next step looks like this. We're just going to rewrite everything only the 1/2 is going to come up. So log base 10 of 49 to the 1/2 plus log of x minus log of y. And where we can simplify, let's do. So 49 to the 1/2, well, let's see, half of 49, no. I don't want half of 49. I want 49 to the 1/2. Okay? So I'm going to come over here on the side and I'm going to write down some stuff. So 49 to the 1/2 is the same thing as the square root of 49, which is 7. Okay? Grab a calculator if that didn't ring a bell for you. So this is log of 7 plus log of x minus log of y. Okay? I'm going to stretch this out 2 more steps. Go ahead and jump straight to the final answer if you want to. But when I'm adding, I will multiply and create one log. So log of 7x minus log of y. The subtraction means I'll divide. So I have log of 7x over y. We're just dividing. And don't be afraid to leave ugly answers. That is correct. Ugly as it is correct. All right, 2 more in this section. This 3 is going to move up and become 4 to the 3rd. This 2 is going to move up and become an exponent. It'll become x squared. So let's just go ahead and write that, and then we'll go from there. So this is equal to log of 9 of 4 to the 3rd, log base 9, 4 to the 3rd, plus log base 9 of x squared. Now, it's easy to look at all these numbers and say, well, I'm confused, like 9, 4, 3, the 9 stays. It's 4 to the 3rd that we need to deal with. So we come over here and we say, well, 4 to the 3rd, type it in the calculator if you need to, but you don't need to because it's 64. And so what I really have is log base 9 of 64 plus log base 9 of x squared. When I'm adding logarithms, I will multiply. So this is log base 9 of 64 times x squared. So 64x squared. Done. All right, one more. I always like to start with a little green pen that goes zoop and zoop. And those are the only 2 exponents that I saw. This one's going to get a little wacky at the end, actually. So this is log of x squared, log of 4, minus, in parentheses, log of x cubed, plus log of 2. Okay, so I said we'll go from left to right, and I wasn't lying, but we can go ahead and put these 2 together. And in the same step, because these are in parentheses, we can put these together. Now, I know you're probably like, well, do parentheses first, so why wouldn't we just do those first? Well, then eventually we'd have to come back to those anyway. So let's just go ahead and do those 2 right there. X cubed times 2, so 2x cubed, log of that. And we'll go ahead and put those together. So 4x squared. So log of 4x squared. And now we will divide. So log of 4x squared over 2x cubed. And you could say we're done, and no one would disagree unless they really got picky and wanted you to simplify this thing, which we will do. This is a good example in simplifying. So let's kind of bring it over to the side and deal with it some. So I'm going to call it 4xx over 2xxx. It's the same thing, right? I have a couple x's on the top, 3 x's on the bottom, and then I have the 4 and the 2 coefficients. So let's grab a red pen. And we're going to say, well, 2 goes into itself 1 time, 2 goes into 4 2 times. I'm going to cancel out a pair of x's and another pair of x's. And the only thing I'm left with is 2 on the top and 1x on the bottom. So my final answer is 2 over x. Oh, but it's the log of that. On the next section, we're going to expand them. We've simplified, now we'll expand.